Hello and welcome to STEM with Mr. N, where I perform different demonstrations and explain the science behind what we're seeing. This week I'm going to be exploring some facts about volcanoes and demonstrating how volcanoes build up over time. Let's check it out. The Earth is made up of 5 main layers. There's the crust, the upper mantle, the lower mantle, the outer core and the inner core. The mantle layers are made up of liquid molten rock which we call magma. The crust is made up of what are called tectonic plates which move and shift around. There are 7 major tectonic plates and over 100 minor tectonic plates. Sometimes these plates will pull apart from each other, and at other times they will rub together and one will get forced underneath the other. When either of these two things happen, they create a gap. The magma is lighter than the rocks above it, so when a gap forms, the magma quickly fills that gap and starts rising towards the surface. The magma will expose a vent in the crust of the Earth and burst out. When magma comes out of the crust of the Earth, we call it lava. The build-up of lava over time forms the familiar volcano shapes that we are used to seeing. There are 2 main types of volcano. There are stratovolcanoes, which are tall cone-shaped volcanoes with steep sides, and there are shield volcanoes, which have shallower sides coming down from the vent. The type of volcano formed depends on the magma which comes up from the mantle. Imagine blowing bubbles into a bottle of oil. You would be able to see the bubbles form and rise to the surface as the gas escapes out of the oil. Now imagine trying to blow bubbles into a jar of jam. You wouldn't see the bubbles rising to the surface and escaping, and the gas that you blow in would be trapped because the jam is thick. The same thing happens with magma. Sometimes you will have thick magma which traps a lot of gas in it, and at other times you will have thin magma which the gas finds easy to escape from. The thin magma, when it erupts, comes out in slow-moving lava, and this forms shield volcanoes as the lava travels a greater distance. The thick magma has a lot of gas trapped in it, and this gas builds up a lot of pressure before it erupts and tends to lead to the violent eruptions that most people imagine if you tell them that a volcano is erupting. This tends to form the stratovolcanoes with the steep sides. The magma tends to move faster but doesn't travel as far, and that's why you get the steeper sides on it. This week I'm going to perform a demonstration which just shows how volcanoes can build up over time regardless of whether they're a stratovolcano or a shield volcano. This is a demonstration that a lot of you may have seen because it is very popular and you may even have tried it yourself, but I'm going to extend it a bit to show how volcanoes build up over time. I'm using a foil tray so I don't make a mess of the counter, and I'm also going to use a small egg cup as a starter for my volcano. I've then also got some baking powder and some vinegar, some food colouring, some modelling clay, some paper towels and a marker pen. The first thing I'm going to do is put my egg cup into the middle of my foil tray. Then I'm going to use some modelling clay to build up some edges on my volcano coming down from the opening in the egg cup. Next, I'm going to add 1 teaspoon of baking powder into my egg cup, and then I'm going to put in a few drops of red food colouring and a few drops of orange food colouring so that my magma and lava have a bit of colour to them when they erupt. Now that's done, it's time for my volcano to have its first eruption. So I'm going to fill up a tablespoon with vinegar, add this to my baking powder and watch what happens. Once I'm happy that the eruption is finished, I'm going to use the marker pen to mark on the aluminium tray how far the lava flowed. I'm then going to use a paper towel to pat dry the outside of my volcano and the aluminium tray. And then I'm going to use more modelling clay to build up the outside of my volcano where it was touched by lava, and also wherever on the aluminium tray was touched by lava. This now means my volcano is a bit bigger than it was before it had its first eruption. Now I'm going to add more vinegar into my egg cup and watch the volcano erupt again. You may also need to add more baking powder at this stage to help get the eruption going. I'm then going to go through the same process again of marking where the lava travelled to, patting this dry with a paper towel and building up my volcano again with some more modelling clay. My volcano is now even bigger again and has spread much further towards me than it has on the other side. This isn't surprising as volcanoes are not perfectly symmetrical, so I wouldn't expect the one that I'm making here to also be perfectly symmetrical. It just depends on where the lava flows to. You can repeat this as many times as you like, but I think I'll just do one more eruption to see where the lava goes to. So I'm going to add some more baking powder and vinegar and have one final eruption. This demonstration is not as violent, fiery or dangerous as actual volcanic eruptions, but as you saw, it is a great way to demonstrate how a volcano builds up over time as lava is deposited on the slopes of the volcano or the surrounding land. What is actually happening in this experiment is a chemical reaction between the acid in the vinegar and the baking powder. When these two substances meet, they produce carbon dioxide gas. This causes the liquid of the vinegar mixing with the powder to froth up and rise up through the egg cup and spill out over the edges down the slopes of my volcano. Volcanoes are named after the Roman god of fire Vulcan and can be split into three main categories. These are active, which are volcanoes which have recently erupted, dormant, which are volcanoes which haven't recently erupted but may again, and extinct. These are volcanoes that are not expected to erupt again. Volcanoes are not only found here on Earth, they are found elsewhere in our solar system, such as Olympus Mons on Mars, which is an extinct shield volcano and is the largest known mountain in our solar system. There are also active volcanoes on Io, which is one of the moons of Jupiter. So Earth is not the only place in the solar system with active volcanoes. Well, that's all for this week. I hope you've enjoyed it. If you like and comment on the videos, it helps rise them up YouTube's hits. And also, if you're not subscribed to the channel, please think about hitting that subscribe button. As always, I would like to take this opportunity to answer any science questions you have about any science topics at all. So feel free to email me at stemwithmrn@outlook.com and I'll get back to you with answers to your questions. You can subscribe to the channel by pushing the button here, and I've added links here to the other STEM demonstrations I've done so far and links here to the robot review videos that I do every second week. This has been STEM with Mr. N, exploring volcanoes.